Good morning everyone. Today we have topic K nearest neighbor algorithm in machine learning. KNN, which stands for K nearest neighbor, is a supervised machine learning algorithm that classifies a new data point into the target class depending on the features of its neighboring data points. K nearest neighbors or KNN algorithm is a simple algorithm which uses the entire dataset in its training phase. Whenever a prediction is required for an unseen data instance, it searches through the entire training dataset for k most similar instances, and the data with the most similar instance is finally returned as the prediction. KNN is often used in search application where you are looking for similar items, like find items similar to this one. Now we have features of KNN algorithm. First one, KNN is a supervised machine learning algorithm that uses labeled input data set to predict the output of the data point. Second, it is one of the simplest machine learning algorithm and it can be easily implemented for a varied set of problems. And third one, it is mainly based on feature similarity. KNN checks how similar a data point is to its neighbor and classifies the data point into the class it is most similar to. So these are the various features of the KNN algorithm. Now this is the diagram of features of KNN algorithm. First one, non-parametric simple supervised learning algorithm. It uses in form of the classification and regression algorithm. It is based on feature similarity and lazy algorithms. So unlike most algorithm, KNN is a non-parametric model, which means that it does not make any assumptions about the data set. This makes the algorithm more efficiently and effective since it can handle realistic data. KNN is a lazy algorithm. This means that it memorizes the training data set instead of learning a discriminative functions from the training data. So KNN can be used for solving both classification and regression problems. So we will understand KNN algorithm by an example. So to make you understand how KNN algorithm works, so let's consider the following example in form of the scenario. So in the image, we have taken the two classes of the data, namely class A, which is in form of the square, and class B, which is in form of the triangle. The problem statement is to assign the new data point to one of the two classes by using the KNN algorithm. The first step in the KNN algorithm is to define the value of k. What does the k in the KNN algorithm stand for? K stand for number of nearest neighbor and hence the name k nearest neighbors algorithm. So this is the idea about the what kind of the approach we have to go for, and this is the example we need to look for in the deeply and how we can solve such problem. In the image, I have defined the value of k as 3. This means that the algorithm will consider the three neighbors that are the closest to the new data point in order to decide the class of this new data point. The closeness between the data point is calculated by using measures such as Euclidean and Manhattan distance, so which will be explained by me later on. So at here k is equal to 3, the neighbors include two squares and one triangle. So if I were to classify new data point based on k is equal to 3, then it would be assigned to class A, which is a square. But what if the k value is set to 7? Here I am basically telling my algorithm to look for the 7 nearest neighbors and classify the new data point into the class it is most similar to. So at k is equal to 7, the neighbors include 3 squares and 4 triangles. So if I were to classify the new data point based on k is equal to 7, then it would be assigned to the class B, which is the triangle, since the majority of its neighbor were of the class B. In practice, there is a lot more to consider while implementing the KNN algorithm. So it is not necessarily the case should be 3, 2, 4, 5, and so on. So it is just depend on the what value I am just considering or determining. So it is done by equivalent distance. Earlier I mentioned the KNN uses equivalent distance as a measure to check the distance between the new data point and its neighbor. So let's see how it is possible. So consider the above image. Here we are going to measure the distance between P1 and P2 by using the equivalent distance measure. The coordinates for P1 and P2 are 1, 4 and 5, 1 respectively. The equivalent distance can be calculated like so. So point P1 is equal to 1, 4 and point P2 is equal to 5, 1. So equivalent distance is equal to square root of these points differences. So here we have the 5 minus 1 whole square plus 4 minus 1 whole square and add summation of all these two values, and finally we just need to get the square root, so which is comes out in form of the 5 value. So it is as simple as that I just need to say, and KNN makes use of the simple measure in order to solve complex problems. So this is one of the reason why KNN is used in such a commonly algorithm in form of the supervised learning. So for classification and regression purpose. Now next we have the KNN algorithm pseudocode. So all the tasks, all the example steps we have done so far, which is under come into the KNN algorithmic steps, or under the part of the KNN algorithm pseudocode steps. So first we have the calculator D. D means the equivalent distance we need to measure between the data points. Next we need to calculate the equivalent distance must be arranged into the ascending order. Next point is we can say the initialize the k and take the first k distance from the shortest list, and the fourth step can be understood by the figuring out the k point with the respectively k distances, and fifth point can be understood by the calculate the ki, which indicate the number of data points belonging to the ith class among the k points, and last point which is just known as the if ki is just greater than kj and for all is not equal to I is not equal to j, so put x into the class I. So this is the algorithmic steps of in KNN algorithm, or we can say these are pseudocode steps of the KNN algorithm we need to look for into a positive way. Now let us consider another example. Suppose we have height and weight and its corresponding t-shirt size of several customers. So your task is to predict the t-shirt size of Virendra, whose height is 161 centimeter and his weight is 61 kg only. Here we have a complete data set and having features like height, weight and t-shirts. The first step we have that is calculate the equivalent distance between the new point and the existing point. So for example, equivalent distance between the point P1 and P2. So P1 has the value 1 1 and P2 has the value 5 4. So is as shown by the our diagram as you can see over the slide. So final output after the calculating the equivalent distance we are getting that is a 5. So result is showing that is a 5 and the solution is mentioned over the slide. You can see over the slide as well. By this slide you can see that we are just calculating the equivalent distance as we have seen to the previous slide, and what is the formula as we have noted down to the previous slide. Now next step, step number 2, and in which we need to choose the value of k and select k neighbors closest to the data point. In this case select the top 5 parameters having least equivalent distance. Now why we are taking the top 5 parameters? Because we have to find out the value of equivalent distance, that is the 5. So we need to take care of the only the 5 top parameters which are having the least equivalent distances. As you can see over the slide that we have just find out the equivalent distances, and we need to look for only the top 5 values in ascending order, so just which are determining by the ranks as you can see over the slide. Now next we have step number 3. Count the votes of all the k neighbors or predicting values. Since for k is equal to 5 we have 4 t-shirt and size M. Therefore according to the KNN algorithm, Virendra of height 161 centimeter and weight of 61 kg will fit into the t-shirt size of M. Since 4k is equal to 5, we have 4m size t-shirt. So we according to KNN algorithm, Virendra of height 161 centimeter and weight 161 kg will fit into the t-shirt of size M. These are the few references as you can see over the slide. I have just taken to make my video in simple and easy manner. At the last, I have big thank you to all of you. Thank you once again for listening this video.